Grüezi miteinander. My name is Christian Gross, and what I want to do tonight is talk about MongoDB. Let's move to the next slide. What this session, this night session is going to do is it's going to try to explain the rationale behind MongoDB, or more generally put, more easily put, the rationale behind NoSQL. I'm going to do an introduction of MongoDB compared to some NoSQL databases, and I'm going to do a number of demonstrations of MongoDB. However, because this is a night session, I know it's recorded and people might be what I'm about to say, but if there are questions you have, real discussion points that you want to start, just shoot up your hand and say, hey, look, dude, I got a SQL database. Why on earth do I want to do a NoSQL database? Right? Throw that question at me. I can actually talk about it. I have some experience with these new databases. So let's start off. Who am I? As I usually say, right now I'm a one-man job. I just trade for myself. I trade my own money. That's what I do. Doesn't mean I actually haven't done anything. Since 1992, I was a consultant for very large corporations, Credit Suisse, UBS, Bayerische Sparkasse, you name it, NCR. I probably did some consulting for them. Okay, what is NoSQL? What I first want to talk about is why do we have this term NoSQL? You see, you have the positive and the negative. NoSQL implies that it's not SQL. It's anything but that. It's sort of like going, ew, it's SQL, ew. We're not ew, we're cool. That's what NoSQL is trying to say. It's a bit of a misnomer, and the term can be traced back to Eric Evans. These days, people like to say NoSQL equals not only SQL. Here's a link that you can look at on what exactly this means. Here's the definition. Next. It's a long definition. I mean, if you want to go through the slides, go through it and look at it, you know, you kind of really want to sit there and say, why do I care? Well, Twitter uses NoSQL. Cassandra is an open source project used at Facebook. Digit, Red, Bit.ly, Foursquare, Adobe, Alibaba, eBay, etc. Can someone tell me what's the commonality here? What do all of these companies have in common? What? Yeah, a lot of customers using it. They have lots of customers using it. That's a very good point. What else is common about these? They're internet startups mostly. That should actually ring. You see, this is an interesting phenomenon. They're internet startups with lots of customers. You see, everyone thinks internet startups is like, hey dude, I'm cool. I hack all night, and I sit there, and maybe my system works. You said they have thousands of customers. Do these systems work? I'm going to be very cynical. I have enterprise applications that can't work with 5 users. How come these people manage to sit there and get these things working with lots of users? That's what you have to be asking yourself. You see, the way that I like to classify NoSQL, NoSQL is to SQL like C# is to C++. Okay? I hope there are no C++ programmers here, because I used to be one. Okay, you can't bring me back to C#. You can't. I'd rather sit there and shoot myself 3 times in the foot before I write C++ code again. The reason being is that C++ solves a certain domain very effectively, okay? Like, don't get me wrong that C++ is a dead language. No, no, no. There's certain domains that C++ solves extremely effectively. I just don't happen to be in those domains anymore. And thus, I'm sort of like saying, look, I don't want to use these language. I want to use C#. SQL. There are 1,001 different ways to save data in SQL. They really are. You want to have persistence framework coming to the wazoo. You want to sit there and do all these things. You're kind of like sitting there going, oh my God. I'll give you a really interesting example. Did you know that Oracle DBAs get paid a lot of money? Did you know that? Have you met Oracle DBAs? Have you seen what their paycheck are? Especially on large DBAs? Now, you must sit there and think about this. Just think about this. Someone who hires an Oracle DBA is paying that person a lot of money, and all he does is say, well, you know what? That select doesn't work that well. Let me show you a better select. That's it. That's his entire day job. Here's a select, there's a select. Wow! You know, to me, it's sort of like saying, really? You can get paid for that? Where do I sign up? No, really, I don't want to sign up because that would be so boring. Even though someone would give me money, I'd have to sit at the office. I'd have to look like, oh yeah, I'm doing something. But anyways, so what I'm really saying is the idea behind NoSQL is to say, look, there are some certain problems that SQL solves effectively. How can we make SQL more effective? How can we create a database such that we can manage all these huge pieces of information without the bulk of having an Oracle DBA? That's really what it boils down to. How can we develop? So what you also need to understand, and this is, again, going back to the Oracle, a lot of these companies charge lots of money. But yet, look at these companies like Google, Twitter, Facebook, and Amazon. These companies are some of the biggest databases on the planet, and yet they don't use SQL. Got to think about that. Because you see, I actually believe NoSQL was created not because there was a real need to create NoSQL, but because the entire infrastructure surrounding SQL is so prohibitive that these companies said, oh, you've got to be kidding me. Can you imagine trying to get the Google database and back it up? Think about it. How do you back up Google? Lots of hard disks, I guess that's the answer, and lots of magnetic tape. You can't back up Google. It's impossible. Can you imagine trying to get Oracle running on a Google-sized database? You'd have to pay, I bet you, if you could get Oracle running on that size of database, I bet you Larry Ellison would come by and say, hi, thank you very much. Because that's how much money he would charge you. And you see, that's something to think about. The other thing also is you see these guys have this appropriate storage because they actually think that RAM is the storage. This is something you need to understand very, very carefully. And I'm going to show you in MongoDB on how it's a RAM-based system. You'll see some big limitations. However, if you have a RAM-based system, the access times are blazingly fast. So is NoSQL viable? Absolutely. Ask Google. Actually, here's one that I wanted to talk about. Did you guys see Watson? Did you see that Jeopardy with Watson? Okay, who here has no idea what the heck I'm talking about? Hands up. Okay. In America, North America, there's this game Jeopardy. Ever heard of that? Okay, that's the tune. And it basically says, what river runs through this country? And you go, answer is this. Okay, and you have really intelligent people, not me, okay? Really intelligent people going onto this and saying, oh, I know what that is, this country. Well, IBM created a computer called Watson. And Watson played against humans in jeopardy. Now, the trick by Watson is Watson had to understand language from the basics. Right? This wasn't like, oh, this word means this answer. No, they had to program a cognitive computer. Watson is based on 16 terabytes of RAM. Do you see here 4 terabytes of hard disk space? Look, Watson ain't going to fit on the hard disk. This is where it's going. It's fully in RAM because the access times are that fast. Is it running NoSQL in the background? No, I don't know if that's running in the background. I'm just trying to make the point that as we know databases, we think that we have hard disks. The reality is no, we need to go into RAM. And we need to have, it's like IBM saying, look, we have lots and lots of little CPUs, and we have lots of cores with lots of RAM, and all we do is we shove them in, shove them out. That's how we replace them. That's what I call the Google model. That's NoSQL. Now, so now you understand, okay, NoSQL is basically a data storage technology. It's basically a technology that's running in RAM, and it can support lots of users. Great. Still doesn't tell me the underlier. Well, to understand NoSQL, what you have to understand is that there are 3 attributes in data storage. Regardless of the data storage system, you can only have 2 of those attributes. So let's take a look at it. This is the cap. You can have availability, you can have partition tolerance, or you can have consistency. Let's take this example. I have a database here, and I have a database here. Let's just say 2 databases, okay? These 2 databases are connected. What I want to do is I want to sit there and I want to save this data on this database. Ignore this triangle for the moment, okay? I'm just saving this data on this database. Will the data be here? Yes or no? Who says if the data will be here says yes? Hands up. Okay, why do you say that the data will be there? They're linked. Okay. Will there be the data there immediately? I'm sorry? I don't know. Depends. Gee, I'd love to have you designing my database. You go in, wait. You go in and say, well, will my data there be? Oh, it depends. The CEO goes, what do you mean, depends? Well, it depends on factors. Maybe the moon is in the wrong constellation, and, you know. Sorry. I'm sorry? Thank you. That's what I'm sort of getting at. I'm sorry, I'm not trying to make fun of you. But what I'm sort of getting at is the data that is here, it might be here, but it depends on the strategy that you want to employ. So for example, let's say I have someone calling up this database. If I use a locking mechanism such that this database is locked, well then when the user accesses, they have to wait until I finish writing here. Okay? I think we can all grasp that, right? I write the database here, it locks this database instance there, and then the user, they will get the data right away. Now, can someone tell me what the downside is for me locking here? The what? The what? What do you mean same downsides? No, let's say I lock, I'm saving the data, I'm locking this database. Using his model, we said we're going to lock this database as well because, you know, we want to make a transaction. What's the downside to me locking 2 databases? Thank you. Nothing else can continue processing. Because what I'm sitting there is I'm locking this system up. You see, we have 2 databases because we want availability, right? We want to sit there and say, look, I have this data here, and then if I write this data to here, well, I don't want everyone talking to this server. I would like some people talking to this server. But if I sit there and I lock this, well, good God, man, I'm sitting there going back to square one as if this is the same server. The only difference is, well, you know what? There's a network in between and blah, blah, blah. This goes back to this triangle. right? So if I have consistency and I have partition tolerance, which means I'm locking up, I don't have availability. Okay, let's say hypothetically I sit there and I break this link. I eventually write to it. Okay, I break the link, I eventually write to it. Great, I have availability. What don't I have? If I have a broken link that I eventually write to it, what do these two databases have as a problem? Sorry? Exactly, consistency. They have that as a problem. They are not consistent. This is something that you really need to think about. Imagine you're someone like Google. You have thousands of cores. You don't have consistency. Or you do have consistency, but you don't have availability. This is the core of the entire database argument. This is what you have to look at. You see, some you have availability, some you have consistency, but then you don't have partition tolerance, which basically means that if this goes down, well, guess what? Your entire system goes down. Ugh. Right? So therefore, you can have consistency and partition tolerance. That's MongoDB. Well, this is actually not my slide. I think I have a link to it who actually did this. Go to that link. The guy does a really wonderful job of further explaining this CAP model. Right? So one of the things that we want to focus on is MongoDB. You see where our MySQLs fit into the picture. You see where other Dynamos, Cassandra, SimpleDB, and so on also fit into the picture. What you also need to take a look at up there is the data models. You see, when you have NoSQL, actually NoSQL, you have three data models. You have the key value, the column-oriented tabular, and the document-oriented. I am not going to talk about key value. I'm not going to talk about column-oriented tabular. I am going to talk about document-oriented. But just quick to give an overview. Key value, you guys are programmers. Ever heard of the dictionary object? That's what it is. And you're kind of going, really? Wow, that simple? Yes, that's simple. Okay. For example, where is it marked? Is Redis? Do you see Redis somewhere there? Yes, Redis. Redis is a key value. The column-oriented tabular, I really don't want to talk about that because there's a lot more to it, but just think of it as a super SQL type format. The document-oriented, I think that's the easiest. You just stuff documents in. Think of it as a flexible XML type system. Okay. Key value, here's just for your reference. You put in your keys. I don't want to talk too much. I just want to leave them in so that you have it as a reference. This I do want to talk about because I want to do some demos so that you see what Mongo does. Okay, map reduce. This is a really, really concept that people are going, eh? It sounds really like, You know? Put it into the following context. You have a bunch of nodes on your computer, okay? Let's just do this. You have all these computers. That's a computer node, that's a computer node, and that's a computer node, okay? So here's the problem. I am talking to this database, this one right here, this node, and I do a query. I say, give me all of the dogs that have 4 feet. And you go, wait a minute. I thought all dogs had 4 feet. No, sometimes dogs can get their feet chopped off. So they might have 3 feet. I'm sitting there making a query with 4 feet. I'm actually using this query very, very specifically. Can someone tell me what the problem is of me making this query of 4 feet to this node? What's the problem? You're programming. Seriously, program this. You're writing the code. You have data on all 4 nodes. I'm making a query at this node. What is my problem?
Do you have different data on every different node?
Thank you. Good answer. Do I have different data at every node? Yes, I do.
Then it's ugly.
It's ugly. Thank you. That's what it boils down to. It's ugly. Because you have to sit there and start communications between seeing and picking up. And you see, one of the problems is you would assume all dogs have 4 feet, but the ugly part is there might be a dog that had its feet cut off. And you kind of then have to go to every node and ask. This is what MapReduce is all about from a very high-level perspective. When I sit there and I make this query, instead of me having to sit there and figure out things, I can tell the database and say, look, you know what, dude, database? This is ugly. I really don't want to sit there and figure out these things. Can you do this for me automatically? Think of it as a stored procedure, but a sort of super stored procedure for NoSQL. What it does is you ask it a very specific question. It goes through the database, accumulates, organizes, optimizes, takes that as a data set, and then chops it down. That's where we get the MapReduce. So what it would do, in this case with the dog, even though you would have a whole bunch, it would say, sit there and say, give me all dogs with feet. So you would have a new class, call it in C#. Is it okay for me to use C# acronyms? Is everyone okay with that, C#? You know the anonymous types? You've seen anonymous types, right? What happens is in a map operation, it creates a number of anonymous types, in this case, feet, goes to each of the databases, puts this record set of anonymous types together. You then operate on the anonymous type almost as if it's a link statement, and then you get an answer. That's MapReduce, that's it, point blank. I think when you put it into that context of anonymous types with a link type mechanism, I think it's the easiest to understand this kind of terminology. There's again a demo, but we're going to do the demos. Okay, sharding. Sharding is going back to the point you were making. You're saying, is the data all on the same server all together, or is it distributed or whatever? And the answer is definitely it's all over. However, one of the big advantages of NoSQL is so that you don't have a mess, because you're saying it's ugly to go with all the databases, NoSQL by itself has already an algorithm developed such that you can shard the data and somehow make it look as one. It doesn't mean that it happens automatically. What it means is you have means to control how queries are sent across the shards. I really don't want to get into much to that. I just want to sit there and make you aware that sharding is an important term. It means to go across the entire databases and then try to figure out what algorithms to use to get an overview of the data. It is important to understand that depending upon the NoSQL database, that sometimes your queries are indeterminate. That means you'll get a mostly good answer. Again, a detail that you need to look at. Okay. Why do you carry? It's about failover, consistency. If you do it poorly, it's going to scale poorly and so on. So that's just things that you can look at. Oh yeah, and last thing among network communications among the different NoSQL databases is sometimes it can be REST, sometimes it can be binary JSON, Thrift or Java. In the case of what we're looking at with MongoDB, it's basically JSON and binary JSON. That's what is used. Thrift is used by, I think it's Cassandra. It's yet another way of protocolizing information. I'm not that interested in it. And then a lot of them just use plain vanilla Java. So now comes the question, do you still need SQL? I use a lot less SQL. I do. It doesn't mean I don't stop using SQL, because SQL has certain tasks that it just dominates still. So for example, NoSQL is good for data that can be grouped or easily grouped or ad hoc or complex data. Data which is very hard to describe. Actually, here's a really thing. If you're sitting in front of a SQL database and you're going, oh God, another field. If you're doing that, go to NoSQL. Seriously, that's what it boils down to. If, however, you have a very easily described data set, for example, market data. Open, high, low, close. That's it. And volume in that bar. And time spent, sorry. If you have those things, I mean, it's not going to add more. There's not magically going to be a field that says, Larry Ellison spoke. No, that's not going to exist. It's just going to be that data, forever and ever till death do us part, okay? Then SQL is very, very effective because it's very defined, it's very consistent, and it doesn't change. And there's a lot of it. If there is like lots and lots and lots, SQL has its advantages. Now, at this point, you're going to go, whoa, whoa, wait, stop, time out. You just told me that companies like Google and so on have bigger databases than SQL, but you just said if you have sequential data and a lot of it, you should use SQL and not NoSQL. Aren't you talking contradictory? And the answer is no. What I'm getting at is, let's say I have market data, tick, 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 tick. Sharding doesn't help. Putting it across databases doesn't help, right? You know, I'm not going to sit there and say, well, you know what? I'd like a tick from yesterday. And then maybe I'll take a tick from a week ago. And then maybe I'll take a tick from yesterday plus 2 minutes. And then I'll take a tick yesterday plus 3 minutes. That's not how I query that type of data. It is a very structured, very sequential approach of data. That is SQL. You can't beat SQL in that performance. However, if I say, look, I think at this time certain events happened, if I start phrasing my data in that, then it's a NoSQL thing, because what I do is I target into a subset, a very small subset that I want to grab. I am not ripping across the entire thing. If you want to look at it from a Facebook point of view, how many of you are friends with everybody on Facebook? I mean, I'm talking all 750 million users. How many? Nobody. Okay, who here has more than 500 friends on Facebook? 300? 200? 100? Okay, 100. 100 friends out of 750 million users is a needle in a haystack problem, right? It's pretty easy. You say, you want this, 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 and this, this. You're grabbing very specific pieces of information out. You're not saying, give me 250 million users, right? That's not what you're saying. You're saying, give me 100 out of 750 million. That's beautiful. NoSQL. Now, if you then go back and say, well, wait a minute, what about Google? Google, you're going to ask for a lot of data. Okay, who here has been on page 25,372 of a query that is whose dog, what dog does Lindsay Lohan have? Most likely, you only go further to the 5th page. How many of you have been to the 35th page of Google? 20th page? Yeah, depending on the topic. Less than 10? Mostly, right? Now think about this again. So Google says, we think we have 85 million results. Bullshit. I think they just sort of said, we're going to say this, we're going to look impressive. Because we think statistically speaking. Right? And you see, do you see the mindset, the difference between SQL and NoSQL? That's what you have to understand. When you have that type of mindset, NoSQL is screaming fast. Because the problem that you have with SQL is if you have to put 750 million users into a SQL database, for it to access 100 users, oh, that takes forever and a day. NoSQL can automatically go vroom right across all the machines, it's all in RAM, and it can just grab the data back very quickly because it's distributing it. NoSQL, on the other hand, has to say, well, I need a lock, I have to make sure nobody's updating the database, and. So you see, that's why there is where you need to understand. What about costs? Here's what I actually find very interesting. This is real live costs. If I sit there and I go with a personal example, NoSQL, I have 8 servers. If I buy cheap servers, they're 493 Swiss francs, which means it's a lot of money for you guys. You are in Banana Republic land. It's, you know, whatever, in Euroland. Just kidding, okay? 8 servers, 493 Swiss francs. It's 3,944 Swiss francs. Now, if you sit there and go, wait a minute, Christian, I'm not going to buy a cheap server. Why should I buy a cheap server? I want a real server. I want a Dell box for 4,000 Swiss francs each one. These are real prices. You haven't been listening to me. What did I say about NoSQL? NoSQL is about sharding the data across the machines, replicating the data, so that when a machine goes down, you go like that, and you throw another machine in. That's what NoSQL is about. NoSQL is not about buying a very expensive box. NoSQL is about buying lots and lots and lots and lots of cheap little boxes that if anything goes wrong, you just throw it out. Think about it from an admin point of view. How hard is it to take a box, unplug it, throw it away, put a new one in, and then let the NoSQL database just replicate itself again? That's easy. If I had to have a Dell box that went down, I have to sit there and phone up Dell support and say, I think my box went down. They say, okay, we'll send someone there. And they say, okay, and they'll look at it and they'll go, what do you think? I don't know, maybe we'll try plugging things in and out. Oh, okay, we'll plug things in and out. Oh, yeah, I think the RAM is gone. I think we'll have to take this one. Well, what am I going to do in between? You have a second box, don't you? You know, you have that discussion. Whereas with the NoSQL, you just sort of sit there and say, get another box, cheap. The Google model is about buying lots and lots of cheap hardware. Who cares about how good quality it is? Doesn't matter. Throw it away. The ramifications of the box, the price is astounding. If you were to sit there and use Dell, or if you were to use Linux, look at the differences. You're going from 67,000 with 24,000 or 3,944. What do you think? Bit of difference? Okay. The ramification is you have to think differently of NoSQL. Okay, this is what I'm trying to get you ready for with MongoDB. If you are going to adopt MongoDB, you're going to have to change your train of thought. You're going to have to say, I'm not going to buy a big box. I am going to buy little boxes. I'll probably throw Linux on it, and then I'll just start it up. Seriously, that's all you do. You just start it up, do a couple of configuration files, and you just leave it running, and it just hums. That's the mindset. Doesn't mean you can't do this with Windows. You can do it with Windows. I have a Windows Server 2008. I kind of formatted it to Linux. But when I was running it on there, it was working fine, Windows Server 2000. It's a great MongoDB server. I'm not going to knock it. I just don't want to pay the Windows Server 2008 licensing. Okay. So now what I want to do is the MongoDB demos. And before I do that, are there any questions? Because this is just now the high-level stuff. Now I'm going to go into the details, where I want to show exactly C# code, where you can get MongoDB, and so on. So I'd like to get first the high-level architectural questions out of the way. Go ahead, shoot, guys. No questions? Everyone content? Going once? Going twice? Gone. All right. So let's first start off. Why first did I go to MongoDB? Why not use Cassandra? Why not use any of the other NoSQL? The reason that I chose MongoDB is it actually worked straight out of the box. You see, when I installed MongoDB onto my Windows station, it just worked. Well, actually, let me rephrase that. It kind of worked. The only thing is I needed to create a directory, DataDB. Right? That's the only thing. After that, it just sat there and it did its little thing. And I was utterly stunned at how fast I could actually do something. Right? I was like sitting there going, oh my God, I have to create tables, and I have to do this, and I have to do that. And no, I just connect to the MongoDB server. I sit there and say, look, I'm going to throw some data in you. Can you figure it out? And Mongo said, yeah, I can. And I thought, now that's incredible. I basically can turn my brain off and just save data. Think about it. I am going to save complex data, and I don't have to think about, do I have a relationship? Is it a one-to-one? Is it end-to-end? Is it this? Is it that? I can just take this object, put the serializable attribute to it, and save it. Who would have thought? Okay? And it works. And I thought, beautiful. And then the next thing that actually really impressed me with the MongoDB people, they were friendly. I sat there and I asked some really basic questions. I mean, I'm talking monkey stupid questions, right? And if you people know some of the open source community, when you ask monkey stupid questions, you get, who do you think you are? Why do you ask them? Read or RTFM. Okay, that's what you would get as an answer. Not by MongoDB. These guys were like, look, here's where you need to answer, here's what you need to do, blah, blah, blah. These guys were really, really friendly. So the place to get it, MongoDB, is at mongodb.org. And what they sit there is they have a really nice website, and they say that we're agile and scalable, we're humongous, it does open source, and blah, blah, blah. Great, you can read that for your amusement, all right? What you want to do is you want to download. And here they have a very nice table where they sit there and they tell you which distribution with which operating system. Now, what you're going to see here is you're going to see there's a 32-bit, a 64-bit, 32-bit, 64-bit, and so on. You have to be careful. If you have a 32-bit operating system, which most Windows machines are, you have to download the 32-bit. If you have a 64-bit operating system, you have to run the 64-bit. So for example, this machine right now is a Linux 64-bit. I run MongoDB 64. However, in my virtual machine, I actually run the 32-bit edition. The limitation between the 32 and 64 is such that the largest database that you can manipulate in the 32-bit edition is 2 gigabytes. Could somebody tell me why 2 gigabytes seems to be this magic number in a 32-bit space? Thank you, because everything's in memory. It actually uses memory mapped files. So in theory, if you had enough memory, it could just shove the entire thing, but then of course operating system and things would go funny. So what they then do is they take all of that memory map file, and that's then what's stored on the hard disk. Right? They don't sit there and try to reinvent the wheel with respect. What they do is they just work with memory mapped files. On a machine like this one, which is a 4 gig machine, that basically means I can load a 3 gigabyte database and have blazing fast speed. If I have more than a 3 gigabyte database, what happens is things slow down because it starts swapping things in and out. It goes back to the point where it's okay to swap things in and out until you actually have to do it. Right? Remember I talked to you about this idea where, let's say you have all this data. Well, the SQL database is a little bit more intelligent about the indexing. NoSQL databases aren't quite as intelligent about the indexing because they assume you're going to have a humongous amount of data, RAM on your machine. That's their assumption. This is something else you have to understand about NoSQL. It makes this assumption. If you're going to sit there and say, well, that's stupid. Why are you guys doing that? Make it work better. They're going to sit there and say, no, buy yourself new hardware. Figure it out. That's going to be the answer because that's one of the core concepts of Mongo. All right, so let's say you download it. And then you can actually just directly run it. What I did is I just loaded the 32-bit, and you see MongoDB? Just run that. That's it. You just double-click on it, MongoDB, and then this starts up. If you haven't created the DB directory, it'll come with an error saying, look, I don't know where to store my data. Would you like to, at the command line, specify where you want to store the data? Or just please create the DB directory? And then from there, it just works. So then, as I said, you just click it. You want to kill it? There you go. Control-C, boom, gone. Want to start it again? There you go. There it is. Pretty simple, pretty straightforward. All right. So now we've started this database. The next step is we'd like to talk to it. There is one very nice utility. It's only on Windows, unfortunately. The ones that are on Linux all have to do with a web server, and you have to install Apache, and it's a little bit painful, and I'm kind of like, eee. It's called MongoView. Just Google MongoView. And what it is it's a UI that's very similar to, let's say, if you were browsing a SQL Server database or any of the MySQL databases, it's a very similar thing. The only thing is you're not going to get the same type of tree that you've been used to. Like, for example, here you get a collection. And you're kind of like, well, OK, yeah, there's no data. That's why there's a data failure. Actually, wait. OK, yeah. There's also no stored JavaScript. That's basically your server-side stored procedures. And GridFS, that's something I'll get to. But basically, what MongoDB has is the ability to store files on the server. That's a really nice feature. Because if you want to sit there and store files, normally you would have to create blobs in SQL databases and shove it in there. Well, MongoDB has a specialized, what they call a grid-based file system. So you can put it onto the Mongo grid, and it would just properly distribute. It would get sharded. It's really, really sweet. All right. So let's go in, and let's take a look at some samples. What I want to do is I just want to create the simplest of examples. Let me just run this code, OK? I'll talk about it in a second. There we go. Let's look at MongoView, and let's see what has actually been created. Let's do disconnect, connect, localhost. And there we go. You see, this now exists. Simple add query. It's a collection. Think of it as, simple add query is a database. Within the collection is document data. If I double-click that, what I have are now 10 documents. The way to think about this is as follows. This is a database. This is a table. But don't think of it as a table in the sense that this table must hold only this type of data. This table can hold any type of data. So for example, let's say I was creating a database where I wanted to store information about countries. Let's say the GDP of a country. The way you typically would do that is you would sit there and say, in a SQL database, you would create the table with a column named country, and then you would have another column, GDP value. And then you would say, select country, select star from country where country name equals Germany. You know, to get Germany, Switzerland, and so on. On a MongoDB or NoSQL-DB, what you would do is you would say, I have a collection, and in this case, I will have Germany. And right now, there will only be one piece of information, the GDP. But then I ask you, is Germany described only by its GDP? No. Germany has more things. For one, there's a lot of people here, okay? There's a lot of nationalities. There's a lot of towns. So what you then would do is you would say Germany, and then have sub-collections to sit there and say, well, you know what? Germany has a GDP item. Germany has an economic value item. Germany has a population item. You can't do that in a SQL. That's a document-oriented approach. You sort of dig down. In this case, what I did is I just created a SQL-type approach. And in each of these documents, what I did is I created 3 columns: string data, integer data, double data. This is a special field which we'll get to in a second. And I just created more of them. Let's look at the source code. Let's first look at how to connect to a MongoDB. A MongoDB is connected by saying Mongo server settings, what the connection pool size is, which server, which address, and then you just say connect. That's it. You've now connected to Mongo. After you've connected to Mongo, which is a specific server, here you need to ask, give me a database. And in this case, I want to get simple add query. If you were using any other database system and the database didn't exist, you would automatically get an error. MongoDB doesn't care. If you access a database that does not exist, MongoDB will not give you an error. MongoDB will just sit there and say, okay, fine, thank you. If you then ask MongoDB for data from that database, Mongo will go, yes, thank you. Guess what? There is no data. It's pretty straightforward. Then what I want to do is I want to sit there and add some data to MongoDB. In this case, what I want to do, this should be ignored. Look at this one, please. I mistyped that. Look at this command. I am asking to get data. By the way, can everyone read that, or is that too small? It's okay, or? What I'm doing is I'm just getting a collection, document data, and I'm now saving that to the collection itself. Think of it as a record set holder. You're opening up a database, you have a record set to something. Nothing's in it. In this case, when I want to do add data, I'm removing all the old data. And then what I'm doing is I'm going through 10 times and I'm going to start adding records to the record set. But this case, you don't add records, you add a BASTA document. This is a binary JSON document. Then what you do is you say, in this binary JSON document, I have 3 pieces of information. I have a field named string data, I have a field named integer data, and I have a field named double data. And I just store information, that's all. I just shove it in. And then I do collection insert. At that point, it's just saved to the database. What is missing here is the underscore ID. Here. Each and every record, or each and every collection item has an ID. Each document has an ID. This ID is underscore ID. That's the field. That's a given. What it is it's a unique identifier to the record. If you want to sit there and find this record very, very quickly, what you can do is you can insert the data, and when it gives you back the record information, you can actually store that or reference that. And MongoDB will find it really quickly. So I keep going. I've added the data. Now let's say I want to iterate it. What I then do is I get the collection again, and then I sit there and I say, I want to find all. Just give me everything. And I'll get a document, and then I can iterate it. And what I'm doing in this instance, I'm just going to output it. So if I actually run this application, here's what iterate all data looks like. Let's change this font a little bit bigger. There. Do you see, iterate all data gives me a JSON document, ID, which is an object ID, string data, hello, integer data, 0, double data, so-and-so a number. Anyone who does any JSON development will look at that and go, yeah, I know what that is. Yes. Oh, do you have a question? No. Oh, sorry. Okay. But this also tells you something about the underlying system. Because it's JSON, I can actually process part of the document and leave other parts. It's not a one-and-all situation. I can do a selective query, a selective retrieval of all of these pieces of information. Let's continue on. Let's say I want to iterate specific data. Let's say I want to find a specific piece of information. What I do is I get the collection again, but this time to create a query, I do query.equal. And this is the field name with the value. I don't really create a, how shall I say, a select star do such and such. That's not what I do. I can build up a JSON document myself. That I could do, or I can use these helper. This is a helper. So if I go and let's say I take a look at the definition of query.document, here's what it looks like. You see you have all, you have exists, greater than equal to, in, less than equal to, matches, mod, and for those of you, not me, there's also regex. Yeah, here we go. Anyone a regular expression expert? Okay, you can actually give it regular expressions to go across the data tree, and it will sit there and find things according to that. So then when you sit there and say, look, I want to actually get this specific thing, what it then does is it allows me to just iterate that document. I can even do compound. You see here I have query.and, where I have string data equals hello3 and the integer data must equal 3. I just build it up. This then brings us to another topic. Some of you might say, ooh, that's ugly, I don't want that. Or someone might say, well, you know what? What API are you using? This really doesn't look like anything that I know. NoSQL databases have their own APIs. If you're trying to sit there and say, okay, I'm going to have one API for all of my NoSQL, not going to happen. What you can do, though, for example, with MongoDB, is there is a link provider. It's not provided by the official MongoDB organization, but there's a third-party set of programmers that actually created a link system sitting on top of Mongo. So that's a driver then you can use, and you can make link queries. The way to update MongoDB data is to sit there and say, again, get the collection, create a query of what you want to update, do a find with the query, and then sit there and say, look, I want to update this document with these and these fields. So for example, in this case, I do update document. I want to set the double data to 13.4. That's how it works. That's it. You're kind of like looking at this and going, dude, mach mich nicht schwach. That's, if you were in Germany, you'd probably say that. Because you're kind of like going, look, that's a lot of work. That's like, well, I did it on purpose to sit there and first show you the low-level document approach. What you would actually want is this approach. Here, see that? Create a data structure, define 3 fields, save it. That's what you want. Take a look. That same code, remember where I said to add, and look how I do it. Simple data, string data equals such and such, integer data equals counter, double data equals such and such, collection.insert data. That's it. You still have to create, to find, there you will still have to sit there and use your queries. But once you have your queries, you can actually typecast it to certain object types. Let me just run this data and let me then show you a more complex example. All right, let's go back here. Let's look at this. I want to, okay, let me disconnect this, make sure that I always get the right data. Look at this data. That's the data that I added with the serialization. Look at the document data. Can anyone tell the difference? There is no difference. This is very, very important to understand, that when you have a MongoDB database, if I serialize the object to the database, I don't serialize the type. That's not what I do. I serialize the information that the type holds within. So what I actually in theory can do is I can write MongoDB as a document and read it as a serialized object. When you get this source code from me, like when you play with it, you're going to see an example where I actually write the data using the document approach and then read it using that serialized object approach. And there's no errors. It just works. That's the key to understanding MongoDB and its serialization. But I can even go one step further. Let's say hypothetically with MongoDB, I want to create a very complex structure. Do you see this? Products. I have an object ID, which is the ID. I have a set of properties, name, category, discontinued. And look, I have children. If I run this example, let's just do this. Let's go here. I just need to make sure something that I didn't disable. Oh, here we go. Yeah. Let's run this. There we go. Let's go back to MongoView. The reason I keep doing disconnect, I normally don't need to do that. I just want to make sure I don't have a demo effect. Okay? Look. Do you see? A tree structure. If I have an object that references other objects, it serializes. Can someone tell me what's wrong with this approach? What's a gotcha? If I have an object that has a set of objects, like a list that references other objects underneath, and then I serialize everything, what can go wrong when I want to pull it out of the database? You're actually getting very close to the point. Okay. Let's say hypothetically, I have a dog. And dog has referenced as an object hair type. Okay? And hair type can be curly with this color, with this texture. And it's a child object. When you're creating the system, you're not going to create a new curly-haired object for each dog, are you? Everyone get to me on that? Is everyone understanding that See? Good. What you're going to do is you're going to create a certain set of object instances that say, look, here is the curly-haired dog type. Here is the short-haired dog type. Here is the long-haired dog type. Then when I instantiate the object, dog, I'm going to reference one of these objects. Well, MongoDB will serialize that object for each dog instance. When it pulls it up, that information where you had references is lost. That's a problem. That's a bit yee. So what you have to do, and this is where you have to be a bit careful about it, is you can use the Mongo serialization attributes and make sure you don't go crazy with the serialization, right? That you just don't save. Because otherwise what you'll have is, what did you say? Too much data. Yep, exactly. So that's one of the things that you have to be a bit careful about. Now, going back to this example, one of the things that I wanted to show is I can sit there and here. Do you see this? Remember I said to you, I can grab from the collection, from MongoDB, I can grab a document. Now, in this case with products, this is my high-level object that was originally a product object, and it referenced children object types. Well, what I can do is I can iterate the Bison document, just as it, not as a serialized object type, and then I can deserialize the individual object instances by hand. I want to reiterate and reaffirm your belief that, look, even though it's a document, you don't have to serialize the entire type as a document. You can pick and choose. You can sit there and say, well, you know what? I want to create a query, but I only want these two fields. Just create yourself the object type, run the query, and serialize it to that type. It'll automatically put it in. This is part of the JSON serialization. What it does is it looks at your fields, and it looks at the fields that are available, and it'll play cross-reference, connect and match the dots. We want that in SQL. Do you know how hard it is to do that? You have a SQL database, you run a query, you only want 2 or 3 fields. Well, you have to sit there and jumble around with the serialization mechanism. Mongo does it automatically for you. You don't have to think that much about it. This is one of the things that I truly, truly appreciate about the NoSQL approach. The fact that I can create these complex structures, and then when I'm running queries, I don't have to load the entire object. I can have a link to what I need to load and then say, now load it, and it makes it more performant. You don't have to do everything at once. You can do it step by step. So that basically does the serialization, deserialization of Mongo. It really doesn't get beyond that. It's basically that straightforward. Now let's take a look at a map reduce example. All right? Here's how it works. I have a product. Let's say this product is this water bottle with the water in. In this, I have a category, water bottle, and then I have whether or not it's discontinued. So what I want to do is I want to find out all of the things that are discontinued. You know, I want to count up how many there are. So what I do is I sit there and I create a map function, and then you see this emit. That's to say, look, I'm going to iterate through all of the records, and then what I want to emit is the category field. Remember the anonymous types? The category, you're creating an anonymous object. So I have a category and its values of discontinued, which is a field, and I have a counter, which is 1. Again, when you're using anonymous types, this should look pretty straightforward to you. So now what I'm going on is each time I'm iterating through, I'm creating a dictionary object based on a category with the anonymous types of continued. The information that's lost from this is, what's the product? Right? Do you know what product that is? You don't. It's lost. You know what category it is. And you know whether or not it's discontinued. You don't know the product. That's part of the map reduce functionality. Then what I do is I actually want to get a reduce. I want to get an answer. So now I could define a function. And what I do is I go through each category. Remember the dictionary object? Like you have a dictionary that references other lists. And then what I want to do is I want to say, okay, is this discontinued? Yes. If so, increment the counter. So I sit there and I go through and I find out for each category how many things are discontinued. And then I return, look at the brackets, another anonymous type. When you look at that and you're going, wow, dude, I can actually do that pretty easily with a bit of link code and C# code and so on, and it's pretty straight. Yeah, you can, actually, you can. There's a reason why you want to do this. When you have a distributed database, Mongo, if I'm going to sit there and make a query to it, I have to tell Mongo to sit there and start hunting through. When I do a map reduce and I store it on the server side, it knows how to optimize, right? You know stored procedures. Why do we use stored procedures? Somebody give me an answer. Why do we use stored procedures on a SQL database? Because you can do everything that a stored procedure can do by hand, right? Why? It's faster. Why? I wouldn't answer compiled. I would say it's optimized, which can include compilation, right? But the thing is, I think you all understanding is the moment you throw the stored procedure, the moment you let the database do its thing, it's faster because it can start sitting there and thinking through how to organize things. Same diff, right? That's basically all that this is all about. Okay. Let me see if, yeah, that takes all of that. And then the last one of what I wanted to show you is the file system in MongoDB. Let's comment this out. Let's compile this. Let's run it. Let's disconnect, connect, and there you go. This time, we are not going to have anything in the collections, but we will. There. I stored files onto the Mongo database. And you go, oh, wow, cool. C, local content, blah, blah, blah. Well, no, MongoDB doesn't say C, local content, BASTA, Mongo, so-and-so. That actually I did. That's a key. This is my key. All Mongo does is it sits there and it creates a key value pair type storage system that happens to refer to files. And the way that I do that is I connected it as usual, but this time I used a file stream and I upload the data using the file stream. So you see here is my FS, which is the file stream, and here's my file name. That's my key. Since we're using a streaming object, are we restricted to files? Yes or no? I saw a head. What did you say? Thank you. You can use every stream. That's the idea. You can use whatever stream you want. It's based on the streaming. It gives you a nice, easy way to store streamed information. You see, MongoDB by itself cannot store huge amounts of information in the main database. MongoDB, if you try to give it like, let's say, a 160 gigabyte file, it'll say, no way, dude, not going to happen today. There's a limit. I'm not going to name the limit. I want you to take a look at it so that for your operating system, you'll have it. But there's a limit. So therefore, any bigger file, any bigger content has to be put into the file system or the gridfs system. The gridfs system can be iterated by all, which is actually kind of pointless, or you can sit there and go through and run a query. But unlike the document before where you define the fields, in the gridfs system, there are specific fields. Like in this case, what I did is I created a query and I said, give me any file that has a length, which is a predefined property, greater than 10,000 bytes. So it'll go through that and then do it. You see, you can basically query on when it was created, the size. There's a couple of other fields you need to, in the debugger, look at it, and of course the key name. That's all you can basically query on. All right. I think that basically is that. Oh yes, when I sit there and when I add, upload with another ones, there's a really interesting phenomena. Let me just make sure that I'm not talking BS. Here we go. There we go. You would have, remember I told you about a key? Oops, it is a key, but it can have twice the same name. You're kind of going, well, that's kind of useless. You have to get the ID. Remember, each MongoDB object, a database object, has an ID. For me, the way to properly update the file is to sit there and reference the file ID, the ID. See this up here? Right in here? The ID field. Each file has an ID field. In this UI, that ID is not shown. But what you can do is you can query, ask for the key, and then it'll give you the file IDs. And then you update based on the file IDs. The reason they did this, and it makes sense, is you might actually want to have multiple keys with the same name. Here's an interesting phenomenon. Has anybody tried to upload and download a lot of data in Google Docs? Has anybody ever tried that? I have. And I had one of the weird things. What I had is I did a subversion replicate with Google Docs. And one of the things I kept doing is I kept uploading a certain file, but it wasn't by accident because my code wasn't working right. And then I tried to delete it, and I hit delete from my synchronized Google Docs. And I thought, great, my code is working. So then it went to Google Docs again, and the file's back. And I'm going, eh? So I sit there and I go, oh, come on. Okay, I didn't delete it. It just gave me success code for the hell of it. I didn't do it. So I went, did it again. And I was like, oh, come on. It's still there. But there was an interesting phenomenon. Not all files were there. You see, I uploaded the files in stages because of my code I was debugging. And I was like, wow, not all files are there. Come on, my code can't be that bad. I was thinking, I'm not seeing something here. And what I wasn't seeing here is exactly this type of phenomena. Google Doc versions your files. If you upload the same file 10 times, it will actually save 10 versions of it. And you're kind of like going, really? Yes, definitely. The way to access most of these 10 versions is through the API. And the utility I was working with actually knew how to do that. And I was actually surprised. And I found out there was a dialog box switch that said, would you like to disable versioning? Now I understood why it said, would you like to disable versioning? The key is that a lot of these NoSQL databases, they allow you to version the files onto the system. And MongoDB is like that. It allows you to version so that you can shove up files and you can say, well, get me the latest one that I shoved up, and it'll get that as a query. But there will be 5 or 6 other versions behind it. When you're dealing in, let's say, caching mechanism and where you want to store old information, that makes a lot of sense. Let's say you want to archive. It makes a lot of sense. But as a programmer, as a SQL programmer, we're not used to that. You know, when we sit there and say, look, we're going to update this data, we're going to store this data, it's that piece of information. That's it, BASTA, finished. We don't just create a second copy for good luck, right? NoSQL does that. And especially MongoDB can do that. All right. Those were my demos. All right. What I want to end up with is say, look, NoSQL is not NoSQL, just not only SQL. NoSQL is about solving very specific use cases. I've defined them. These are very specific situations that you want to solve very efficiently. Ironically, a lot of these use cases is what drives internet companies. Remember the Facebook example. Remember the Google's example. Even though it says you could talk to 750 million friends, most of us aren't going to get past 100, right? It's about finding the needle in the haystack. It's a generational leap. It required in me a lot of changing thinking of how I store data, how I deal with data. It is, in a lot of aspects, inverse to SQL. But it doesn't mean that you never use SQL. I still have some instances where I use SQL. Overall, it can work very, very well. I don't disagree with it. I actually recommend it. I look at things like MongoDB and I say, look, it's a great database. I highly recommend it. But please think about it. Please experiment with it. Try to figure out what MongoDB represents, how the data is stored, how you shard it, and so on. If I was sitting in a company and I had to sit there and implement something with MongoDB, I would actually take about a month. Say to whoever, if you're the boss, say, I want a month. If you're not the boss and you have to talk to the boss, say, look, I need about a month to play around with MongoDB because I want to get all the ins and outs. I know a month is probably going to be overkill. Most likely within a week, you'll figure it out. The reason why I like a month is in the first week, you're going to be so excited, everything's going to work. And then the second week, you're going to go, oh, shit, something didn't work. And you're going to look like an idiot if you talk so grand. If you give yourself a month, you can take a look at those hiccups that you didn't see initially, right? It really is a mind shift that you need to undertake. That is my talk. I hope you liked it. If you have questions, I'm going to hang out for a couple of minutes. Otherwise, where's the beer? Huh? Have a good night. Thank you.